Welcome to Module 2. This set of notes is going to start Module 2 off for us. This is the introduction to functions. Okay. Now, the first thing we're going to look at is the definition for a relation. A relation is a very simple idea. It's just the set of any ordered pairs. Now, each relation has a domain and it has a range. When we talk about domain, we're talking about the set of all the first coordinates in those ordered pairs. Now, typically, when we talk about an ordered pair, that's referring to our x's. The range is the set of all those second coordinates, so that's going to be our y values. Now, a relation has the potential to be a function. What makes a relation a function? When each domain value is paired with exactly one range value is when a relation becomes a function. So let's write that out. Each domain value, so that's our x's, is paired with exactly one range value. That's our y's. So another way of saying that is that your x values can't repeat. So let's check out an example. If we look at these two charts, the directions want us to determine whether each of these relations represents a function, justify our answer, so we've got to explain it, and we also want to state the domain and range. Now, for time's sake, let's just list the domain and range for those that we decide are going to be functions. Okay? If I look at this first chart, this relation is a function. If I check out those x values, every x value is paired with exactly one y value. So I'm going to say, yes, this is a function. Each domain value, each x, is paired with one y value, or one range value. Now, keep in mind in this chart that f of x is just that fancy name for y. Okay. So, since this one is a function, let's go ahead and write out its domain and range. Okay. Now, keep in mind that domain and range are sets. So, when we write out domain, or range for that matter, we have to make sure that we put it in those braces to show that it's a set. So, the domain is all the x values. We've got 0, 1, 5, 8, and 10. Okay. The range is all our y values. So we have -2, 2. Now next in our list would be another 2, but when we write out the set, we only need to write it one time. So we're going to move on to 7, and then we have 16. Now, if you take a look at that second chart, this is not a function. The reason it is not a function is because we have an x value that's cheating. 1 is hanging out with 3, then 1 goes and hangs out with 2. So, these domain values are not paired with exactly one range value. This 1 is paired with two different numbers. It's paired with a 3, and it's also paired with a 2. So this is not a function. No. 1 is paired with two different y values. Now, we're given another relation here. This time, it's written as a set of points. So we have S is the set 0, -4, 3, 2, 5, 4, 0, 6, and 15, 16. Okay? If I check out those X values, those domain values, I'm going to notice that 0 repeats. So 0 is hanging out with -4, and then 0 is hanging out with 6. 0 is cheating. Okay? So this is not a function. Okay? 0 belongs to two Y values. It is paired. Let me write paired instead of belongs. 0 is paired with two Y values. So that quick, easy way of determining whether something's a function or not when it lists out a set of pairs like this, or when it gives you information in a chart like in the previous example, is to check out those X values and see if they repeat or not. Now, if we look at R, we have 0, 1, 3, 2, 6, 4, 7, 9, and 14, 15. This one is a function. If we check out those Y values, each X is paired with exactly one Y. There's no X values that repeat. So each X value is paired with one Y value. Okay. So since this one is a function, let's go ahead and list its domain and range. Okay. So domain is 0, 3, 6, 7, and 14. And my range is -1, 2, 4, 9, and 15. Now, the next couple examples we're going to look at are actually graphs. So we're no longer being given a list of sets of points. Okay? When you look at a graph and you want to determine whether or not it's a function, you need to use what's called the vertical line test. If I can draw a vertical line and it touches the graph more than once, it fails the vertical line test, which means it is not a function. So, for example, in this first graph in the upper left-hand corner, if I were to draw a vertical line here, this fails the vertical line test. It touches it once, twice, 3 times. As soon as that vertical line test can touch the graph more than once, it fails that vertical line test, which means it is not a function. And I'm going to be a little bit lazy, and we're going to call this the VLT, the vertical line test. Okay. Now, if I look at the graph over on the right-hand side, this one is a function. No matter where I draw that vertical line, it is always going to ever only touch that graph in one place. So this one is a function. Now, because it's a function, let's go ahead and talk about its domain and its range. Now, graphically, when we're talking about domain and range, domain is left to right, and range is bottom to top. Okay? So, our domain, our X values, left to right. Although you can't see in this actual picture, because this is just a screenshot, okay, this graph continues on forever in both directions. Okay? It continues to oscillate. So my domain going all the way to the left would be negative infinity, going all the way to the right would be positive infinity. Notice that I put parentheses around that negative infinity to infinity. Anytime I have infinity or negative infinity, I will always use parentheses, because we can't ever include negative infinity or infinity. We can't actually get there. We can't touch it. Okay? Now let's talk about range. Now with range, we're looking at those y values, so we're going from the bottom to the top. Now notice that this graph never goes below -2, and it also never goes above +2. So my range is going to go from -2 to +2. This time I'm going to put brackets around those two numbers. Now the reasons I use brackets here was because that graph actually goes down as low as -2. It's included. It goes up as high as +2. It's included. So in a point like that's included, we use brackets instead of parentheses. Okay. Let's take a look at two more graphs. Okay. This one right here is just a linear graph. It's just a straight line, okay? And again, this is just a screenshot, but this graph technically continues in both directions. Okay? This one is a function. No matter where I draw that vertical line, it is always going to only touch it in one place. So this one passes the vertical line test. So let's talk about domain and range on this one. Okay. My domain, again, is all my x values, so it's left to right. So left to right, because I see those arrows on the ends of that line, that's going to technically go all the way to -infinity on the left, and it's going to go all the way to +infinity on the right. And again, because we're using infinities, they're going to be parentheses. Okay. On my range, I'm talking bottom to top. That graph continues to go lower and lower and lower all the way to -infinity, and it also goes higher and higher and higher at the top to +infinity. Because it's -infinity and +infinity, we use those parentheses. Okay. Now the last graph I have to show you here is just a set of points. It's just graphed on the coordinate grid for us. Okay. Now there are places where I can draw vertical lines and it will only pass through one point. But notice this set of points down here on the bottom. As soon as I draw a vertical line there, that vertical line passes through my graph twice. That x value got two different y values. So this is not a function. Okay. So it fails right down here with those two values. So remember that when you're looking at a graph, if you're asked about whether or not it's a function, you're going to use that vertical line test. If the vertical line can touch your graph more than once, it is not a function. Now, when we talk about functions, functions can be written or presented in many ways. You might see a function as a graph. You might see it as a table. You might see it as an ordered pairs. You might even see it written with a formula. So there's lots of different ways that a function can be presented. Okay. Now, let's check out this example here. They give me a function that is graphed. Okay. And that function that is graphed, we're going to call g of x. Okay. Now, the first thing we're going to do is we're going to rewrite the points that they give me in that graph g of x in table form. Okay. And then we're going to rewrite it as well in function notation. Now, when you write a function in table notation, you want to make sure that your x's are ordered from least to greatest. Okay. Now notice they've already given us our headings for this graph. Okay, remember our graph is called g of x. Okay. So we're putting in an input of x and we're getting out an output or a y value of g of x. Okay. So if I look at my very first point, it's at -3, -4. So I'm just going to copy that over into the table. Okay, that was this point. If I look at this next point, that's at -2, -2. then I have negative 1, 0, then I have 1, 4, and then I have 3, 8. Okay. So we have now written our function g of x, which was given to us in graph form, as table form. What we need to do now is write it using function notation. So function notation means that y is paired with what x. Okay, so let's make a little note of that. This means y is paired with this x. Okay. So, if you have your chart written down, you're going to want to go back and reference it. We had that negative 3 and negative 4 were a point. So we would write g of negative 3 equals negative 4. G of negative 2 equals negative 2. G of negative 1 equals 0. G of 1 equals 4. G of 3 equals 8. So when I plugged in negative 3, I got an output of negative 4. When I have an input of negative 2, I have an output of negative 2. When I have an x value of negative 1, I got an output of 0, so on and so on. Now, the next question asks me to evaluate g of 3. Now remember that this number inside is an x value. So if we look at our list over there, g of 3 equals 8. And that 8 was our output, our y value. Okay. Now the next question asks us for what value or values of x does g of x equal negative 4? So we don't know what our x is. That's what we're trying to figure out. What we do know is that our y value is negative 4. Okay? So if you check out this top line right here, we have a y value of negative 4, so that means my x value would be negative 3. Okay? So you need to pay close attention to what's your x value, what's your y value. Okay? Remember, x values are also sometimes referred to as inputs, and y values are sometimes referred to as outputs. Okay, this time we're going to evaluate a function again, which is what we did in those last two examples, but they're going to give us the graph this time. Okay, so remember we said that functions can be written in graphs, tables, function notation, formulas. Okay. The graph that we see asks us to evaluate h of 4. Okay? So what we need to do is remember that this 4 represents an x. If we go to 4 on our x-axis and follow it up to the graph, and then follow it left to the y-axis, we're going to see that h of 4 equals 2. Okay. The next question asks us for what values of x does h of x equal 4. So remember, we don't know our x, that's what we're trying to figure out, but we know that our y value is 4. So this time let's start at a y of 4, follow it over the graph, and then we're going to go down. So that means that our x value that we're after is 3. Now, in this last set of examples, we're going to look at functions that are defined by a formula. Okay? the formula that we're looking at is f of x equals 5x minus 2. Okay. Now, the very first one it asks us to evaluate is f of 0. Remember that this means x equals 0. So we're going to plug in 0. So we're going to have 5 times 0 minus 2, and that's going to equal negative 2. So f of 0 equals negative 2. On B, we want to evaluate f of 2. So again, remember this is our x value. So we're going to plug in 2. So we have 5 times 2 minus 2. 5 times 2 is 10. 10 minus 2 would give us 8. C asks us for f of negative 2. Again, that's our x. Okay. So we're going to plug in negative 2. 5 times negative 2 is negative 10, and negative 10 minus 2 would give us negative 12. So f of negative 2 equals negative 12. Now, notice D and E don't have numbers filled in there for the input. They have an expression. So in D we have f of x plus 1. In D we have f of negative x. So, because we're not plugging in a single number, we're also not going to get a single number out either. Okay? Instead, we're going to get out an expression. So, watch what happens here on D. If I evaluate f of x plus 1, I'm going to replace x in my original function with x plus 1. Okay? So this will equal 5 times the quantity x plus 1 minus 2. Now, I can keep going to simplify this. I can distribute that 5. This gives me 5x plus 5 minus 2. And now I can go a step further because I can do 5 minus 2, which would give me 3. So, f of x plus 1 equals 5x plus 3. Now, on the bottom here, this really should be an E. Okay? We want to evaluate f of negative x. So everywhere we see an x in that original function, now we're going to plug in a negative x. So this will equal 5 times negative x minus 2. Okay? Now, 5 times negative x is negative 5x, and then we still have our minus 2. So f of negative x is equal to negative 5x minus 2. Now, the last thing I want to look at with you is number 16 in your homework assignment for this section. Okay? Very, very similar to the examples we just worked out together. Okay? The one thing I really want to point out to you in this example is that there are 4 different functions being shown to you here. Okay? There is f of x, which is the graph they show you. There is g of x, which is that set of coordinates they give you. There's p of t, which is that chart they give you. And then there's also h of x, which is written as a formula. So be aware that there's 4 different things going on here. So depending on which question they ask you about, you're going to have to reference different things. Okay? So the very first one asks me to evaluate f of 3. So remember, f is my graph. So when it says f of 3, my x value of 3 is where we're going to start. Now, there's my x value of 3. I'm going to follow it down to the graph, and then I'm going to follow it over to my y-axis. So I find out that f of 3 is equal to negative 1. Okay. Now it says determine x when f of x equals negative 2. So this time they're giving me a y value, and I need to figure out what the x is. So if I start at y is negative 2 and follow it over the graph, and then follow it back up to the x-axis, I find out that x is equal to 1. Okay. The next one asks me to evaluate g of 31. Okay. So, I'm going to g now, which is that set of coordinates. And remember that 31 is my x value. So when I look for that x value of 31, I see that my y value is 8. Okay. Determine x when g of x equals negative 1. So I'm still looking at my g of x function, but this time they give me a y value of negative 1. So now I'm looking at this point 29, negative 1. When y is negative 1, I find that my x value is 29. Okay. Now I'm going to move over to h. So notice that h is that formula at the very bottom. It asks me to evaluate h of 16. Okay. So the formula I have is 16x plus 28. I need to plug 16 in for that x value. So I'm going to have 16 times 16 in this case, plus 28, and that's going to give me 284. Okay. Now the next one asks me to determine x when h of x equals 252. So it's saying, okay, when 16x plus 28 equals 252, what's my x value? Okay, so we've got to go back and do a little bit of algebra here. In order to solve this equation, first thing we have to do is subtract 28, and that's going to give us that 16x equals 224, and now we need to divide by 16, and that's going to tell us that x equals 14. Okay. And now the last two questions there ask me about p of t. So now I'm looking at that table. Okay. It asked me to evaluate p of 43. So remember that that x value there is 43. So if I look at, and technically here we're talking t's. So when I look at that row of t's, I'm looking for 43. There it is. My corresponding p of t is 82. Now we want to determine t when p of t is 13. So I'm looking in my p of t row this time. There's 13, and I see that my t is 29. Okay. So I hope working through this example with you helps you when you get to your homework. Okay. And that is the end of the first set of notes for Module 2, the Introduction to Functions notes.